All right, everyone, welcome back. Ready for another deep dive. Today, we're tackling something that's been making waves everywhere you look. Artificial intelligence.
Yeah, AI is definitely having a moment.
It sure is. And we've got some really cool research papers to help us break it all down. We'll start with the fundamentals, like what even is AI.
The basics.
Exactly. Then we'll get into the really juicy stuff like those large language models, deep learning, all that jazz.
The stuff that's really capturing people's imaginations.
Exactly. AI can seem a little intimidating, I get it. But trust me, we're going to break it down into bite-sized pieces that everyone can understand. So no need to be a computer whiz to follow along.
That's right. We're all about making this accessible.
Okay, so let's start with that first question. What is AI? Luckily, we've got this brief introduction to AI source that explains it really well. It uses this analogy of learning to play chess, which I thought was pretty clever.
Oh yeah, I like that one. It's a good way to visualize the learning process.
Right. Like when you first start playing chess, you probably make a ton of mistakes, right?
Definitely, unless you're some kind of prodigy.
But the thing is, each loss teaches you something, helps you refine your strategy. And eventually, with enough practice, you start winning.
Exactly. You're gathering data from each game, learning from your mistakes, and adjusting your approach.
And that's basically what AI is doing, too. It's mimicking that human learning process, but on a much grander scale.
Right. It's all about algorithms and data.
So instead of a chessboard, AI is working with these massive data sets.
Yeah.
And instead of moving pieces, it's tweaking algorithms and parameters to get better at solving problems.
It's like a giant puzzle, but with numbers and code as the pieces.
Exactly. And the goal is to create a machine that can, think for itself in a way, make decisions, solve problems, maybe even better than we can.
And that's where things start to get really interesting.
Okay, so now that we've got the basics down, let's jump into something that's been all over the news lately. Large language models, or LLMs for short.
Ah, yes, the LLMs.
This paper, 23607.06435vdensr.pdf, if you want to look it up, gives us a deep dive into these fascinating things.
It really gets into the nitty-gritty.
So, in a nutshell, what are LLMs?
Well, think of them as AI systems that are specifically designed to understand and generate human language.
Like, they can actually read and write.
And so much more. Translate languages, summarize text, answer your questions, even rate different kinds of creative content.
It's like they're learning to think like us, but with words.
In a way, yeah. They're trained on these massive data sets of text and code, billions and billions of words.
Which is mind-boggling when you think about it. Like this paper mentions Gemini 1.5, and apparently it has a context window of 2 million tokens.
2 million? Can you even imagine holding that much information in your head at once?
Seriously, that's like remembering everything you've read in the past few weeks.
It's incredible. That context window allows the model to process a huge amount of information, which is why it can do these really complex tasks.
So it's like having a superpowered memory, but for language.
Pretty much.
This is blowing my mind already, and we're just getting started.
Oh, there's so much more to uncover.
Now, you mentioned these models are trained on massive data sets, right? But this paper also talks about something called synthetic data.
Ah, yes.
And it seems like this Nemotron 4 model relies heavily on it. Synthetic data, if I understand correctly, it's basically information that's artificially generated, right?
Exactly. It's not real world data. It's kind of like made up.
Which makes me wonder, how can an AI learn effectively if it's being fed information that's not even real?
That's a great question, and it's something researchers are actively exploring. The use of synthetic data is sort of a double-edged sword.
How so?
Well, on one hand, it allows us to create these enormous data sets without having to rely solely on real-world data, which can be, expensive and time-consuming to collect.
So it's like a shortcut.
In a way, yeah. But on the other hand, there's always a risk that the synthetic data might not accurately reflect the nuances and complexities of real language, so it's a bit of a balancing act.
So it's like feeding an AI a diet of fictional stories and then expecting it to understand the real world perfectly.
Yeah, that's a good analogy. There's bound to be some disconnect there, but hey, it's all part of the learning process, right?
True. Okay, so we've talked about AI in general and their impressive LLMs, but now I want to dive into something that I find truly fascinating. Deep learning. We've got this deeplearningbook.pdf here, which seems like the ultimate guide to this whole concept.
It's a great resource, very comprehensive.
And honestly, the idea of machines learning these abstract concepts, just like humans do, it just blows my mind.
Deep learning is definitely a game changer. It's this subset of machine learning that uses something called artificial neural networks.
Artificial neural networks? Sounds intense.
They're basically inspired by the structure of the human brain, and they allow these models to learn from data in a really powerful way.
So it's like we're trying to recreate the human brain, but in a computer.
Kind of, yeah. But we're still a long way from achieving anything close to the complexity of the human brain.
I can imagine. So how do these artificial neural networks actually work?
Well, think of it as building a model with multiple layers, and each layer extracts increasingly complex features from the data.
Like those optical illusions where you see one thing at first, but then your brain starts to perceive a totally different image.
Exactly. It's like your brain is processing the information in layers, and each layer reveals something new.
That's a great analogy. And this book has this cool visual that shows a deep learning model recognizing a car.
Oh, yeah, I remember that one.
First, it detects basic edges and lines, then combines those into shapes like wheels and windows, and finally it puts it all together and recognizes the whole object as a car.
It's like building a puzzle, layer by layer, until you see the complete picture.
Exactly. And the crazy thing is, these models can learn abstract concepts, not just patterns. Like a model trained to recognize cats, it can eventually distinguish between different breeds, even if it's never seen those breeds before.
Right. It's like it's learning the concept of catness, not just memorizing images.
It's like these models are developing a real understanding of the world, similar to how we humans learn and categorize things. It's incredible.
It really is. Deep learning is pushing the boundaries of what we thought was possible with AI.
Okay, but with all this learning and processing going on, these models must require a ton of power, right?
You're absolutely right. Training and running these large models, it's very resource intensive. It takes a lot of computational power and energy.
So it's not exactly something you can do on your laptop.
Not quite. But researchers are constantly working on ways to make LLMs more efficient.
How so?
Well, one interesting technique they've developed is called pruning.
Pruning, like trimming a tree.
Pretty much. Think of it like decluttering a closet. You get rid of unnecessary items, in this case less important connections in the model, to free up space and make things run smoother.
So it's like Marie Kondoing your AI.
Exactly. You're getting rid of what doesn't spark joy, or in this case, what doesn't contribute much to the model's performance. And by removing those less impactful connections, the model can become more efficient without losing too much accuracy.
So streamlining the model for maximum efficiency makes sense.
And there's another clever trick they use called quantization.
Quantization.
It involves representing information using fewer bits, kind of like condensing a really long message into a shorter coded version.
So it's like creating a more compact version of the data.
Exactly. And that can lead to faster and more efficient deployment of these powerful LLMs.
It sounds like they're finding some pretty ingenious ways to make these massive models more practical. But let's take a step back for a second. How do these mighty LLMs actually stack up against other AI models that are designed for specific tasks? Are they really as versatile as they seem?
That's a great question, and it's a bit of a debate in the AI community. While LLMs have shown they can do a wide variety of things, they haven't completely outperformed those specialized models in every area.
So it's like comparing a seasoned chef who's mastered a specific cuisine to a talented cook who can whip up a variety of dishes. Both have their strengths.
Exactly. And there's this concept called zero-shot learning, which is when LLMs can sometimes perform tasks they haven't been explicitly trained on.
Wait, really? They can just figure it out on their own?
Sometimes, yeah. But often, they need a little bit of training data, what we call few-shot learning, to really excel. It's like a gifted athlete who still needs some practice to reach their full potential.
So LLMs are incredibly promising. But there's still room for improvement, especially when it comes to those highly specialized tasks. It makes you wonder, will they eventually outperform those task-specific models, or will those specialists always have an edge?
It's a tough call. Some experts think that as LLMs continue to evolve and we train them on even larger data sets, they might eventually surpass their specialized counterparts. But others argue that task-specific models will always have an advantage because of their focused expertise.
It's like a race between the hare and the tortoise, and only time will tell who ultimately wins. But in the meantime, I'm dying to know more about what these LLMs can actually do in the real world. This paper mentions quite a few applications, but I'm particularly curious about.
Well, hold on tight, because we're about to embark on a whirlwind tour of LLM applications. We'll cover everything from machine translation to creative writing, from medical research to code generation, and maybe even a few surprises along the way.
Sounds like we've got a lot to cover, so let's dive right in.
All right, so let's jump back into those real-world applications for LLMs. Remember, we're talking about AI systems that are designed to understand and generate human language, which opens up a whole world of possibilities.
Yeah, it's pretty mind-blowing when you think about it. I mean, we use language for practically everything. So where are we seeing these LLMs making the biggest impact so far?
Well, one area where they're already making a huge difference is in machine translation. This paper actually highlights how LLMs are being used to translate languages with incredible accuracy and fluency. Imagine a world where language barriers are practically non-existent, where you can seamlessly communicate with anyone, regardless of their native tongue.
That would be incredible.
Yeah.
It would totally revolutionize the way we interact with each other on a global scale.
Yeah.
No more fumbling with phrase books or relying on those awkward hand gestures.
Exactly. And it's not just about breaking down communication barriers, Think about the potential impact on education, business, even diplomacy. Imagine being able to access information and resources from all over the world, regardless of the language they're written in.
It's like opening up a whole new universe of knowledge and collaboration.
Exactly.
It's like the Tower of Babel, but in reverse.
Yeah.
But instead of dividing us, language is bringing us together. Okay, what other applications are you excited about? What else is out there?
Well, the paper also talks about how LLMs are being used in medical research, which is really exciting. They can analyze huge amounts of scientific literature, helping researchers identify potential treatments and cures for diseases much faster than humans could ever do on their own. They can even assist in diagnosing patients by, analyzing their symptoms and medical history.
Wow, that's amazing. It's like having a team of super intelligent research assistants working around the clock.
Yeah.
Like scouring through mountains of data to find those crucial breakthroughs.
Exactly. It really highlights the potential of AI to accelerate scientific discovery and just improve healthcare for everyone,
Yeah, it's really incredible. It really is. And the applications go way beyond just medicine, right? I mean, these LLMs are being used in fields like finance, law, even creative writing.
Oh, yeah, absolutely. Imagine a lawyer using an LLM to analyze those complex legal documents.
Right.
Or a marketer using it to generate really compelling advertising copy.
Right. They're even being used to write poetry and screenplays. I read that somewhere.
It's true. It's still early days, of course, but the results are pretty impressive. LLMs can analyze patterns in existing poetry and then learn to generate new verses that follow similar structures and rhyme schemes. They can even mimic the style of famous poets.
Wait, hold on. AI writing poetry. That sounds a little too sci-fi for me. I mean, can they really capture the nuances of human emotion and creativity? I'm not sure about that.
Well, it's definitely a thought-provoking development, but I think it's important to remember that LLMs are ultimately tools, right? They can augment human creativity, but they can't replace that spark of imagination and inspiration that comes from the human mind.
Right. So it's more about collaboration than competition.
Exactly. It's up to us to use these tools responsibly and ethically.
That's a good point.
Yeah.
It is. It's like any powerful technology, right? I mean, it can be used for good or for bad. But hey, let's not get too bogged down on the potential downsides. I want to hear more about the possibilities. You mentioned something about LLMs being used for code generation. Can AI actually write software now?
Believe it or not, it's already happening. LLMs are being trained on these massive code bases, and they're learning to generate code in various programming languages. Imagine a world where you can just describe the functionality you want, and poof, the AI writes the code for you.
Whoa, that would be a game changer for software development. It would make coding accessible to pretty much anyone. But wouldn't that put a lot of programmers out of work?
Well, it's definitely something to be mindful of as AI keeps advancing. We need to think about the implications. But it's important to remember that technology has always disrupted industries and created new opportunities. Just as the invention of the automobile didn't eliminate the need for transportation, AI won't eliminate the need for human ingenuity and problem-solving skills. We'll adapt. We always do.
So it's more about adapting and evolving than going extinct. We need to learn to work alongside these new tools rather than fearing them.
Exactly. It's all about finding that balance, that synergy between human and machine intelligence. And speaking of intelligence, let's circle back to that idea of deep learning for a moment. We talked about how it works in theory with those multi-layered neural networks, but what are some real-world examples of deep learning in action? Where is it actually making an impact?
Yeah, I'm curious about that too. It's all well and good to talk about these abstract concepts, but I want to see how it's actually playing out in our lives. What are some tangible examples?
Okay, so one of the most visible applications of deep learning is in image recognition. It's used in everything from facial recognition on our smartphones to self-driving cars navigating those complex environments. Think about it, how you can unlock your phone with just a glance, or how Facebook can tag your friends in photos automatically. That's all powered by deep learning algorithms that can recognize faces and objects with crazy accuracy.
Yeah, it's kind of wild how we've come to take those things for granted. It really wasn't that long ago that this kind of technology seemed like something straight out of science fiction. And speaking of sci-fi, those self-driving cars, I mean, they're really starting to feel more and more real.
They are.
It's crazy to think that a machine can see and understand the world around it well enough to navigate traffic.
It really is a testament to the power of deep learning. Those self-driving cars? They're basically equipped with these powerful computers that are constantly analyzing data from cameras and sensors, using deep learning algorithms to identify objects, estimate distances, predict the behavior of other vehicles. All the things a human driver does, but at lightning speed and with incredible precision. It's really impressive.
Yeah, it's pretty remarkable. But with all these advancements, there were bound to be some concerns, right? I mean, what about the potential for misuse or even replacing human jobs? Those are big questions.
They are. And it's important that we have those conversations, We need to talk about the ethical implications of AI as it becomes more powerful. We need to make sure that these technologies are developed and deployed responsibly.
Yeah, it's a good reminder that technology is never neutral, right? I mean, it's shaped by the values and choices that we make as humans. And as we develop these increasingly powerful AI systems, I think it's crucial that we put human well-being and social justice front and center.
I agree. But let's not get bogged down in the negative just yet. We've talked about some of the risks, but what about the really exciting possibilities that deep learning offers? How can we use it to make the world a better place?
Okay, yeah, let's focus on the positive for a minute. Where do you see the most potential? What gets you really fired up about deep learning?
Okay, well, imagine a world where personalized education is available to everyone, regardless of their location or socioeconomic background. Deep learning could be used to create these adaptive learning platforms that cater to individual needs and learning styles. Imagine making education more engaging and effective for everyone.
That's a really beautiful vision. It's like giving every student a personal tutor.
Exactly. And that's just one example. Think about scientific discovery. Deep learning is already being used to analyze these massive data sets in astronomy, physics, biology, leading to all sorts of new insights and breakthroughs that we could never have imagined before. And as these models evolve, they could help scientists develop new theories and maybe even solve some of humanity's greatest challenges.
Like curing diseases or combating climate change.
Exactly. It's like we're giving scientists a superpower, this ability to see patterns and make connections that were hidden before. We're living in a golden age of scientific exploration, and AI is at the heart of it.
It's incredible. It really is. But let's not forget about the human element here. What role will human creativity and ingenuity play in this increasingly AI-driven world? I mean, will we become obsolete? A lot of people are asking that question.
It's a valid question for sure, but I truly believe that human creativity will be even more important than ever. LLMs and deep learning, they can augment our abilities, but they can't replace that spark of imagination. The intuition, the empathy, the ability to connect seemingly random ideas and create something truly novel. We need to embrace these AI tools, but also nurture our own unique talents and passions.
That's reassuring. It's not about humans versus machines. It's about finding ways to leverage our strengths and collaborate to create something better. I like that. So where do you see all of this heading in the next decade? What's your vision for the future of AI?
Well, I think we'll see even more integration of AI into our daily lives, from smart homes and personalized healthcare to AI-powered assistants that anticipate our needs and help us navigate the complexities of the world. And as those LLMs keep evolving, they'll likely play a central role in these advancements. It's like this seamless blending of the physical and digital world where AI is both this powerful tool and this invisible companion enhancing our lives in countless ways.
That's an exciting vision. It is. But it also comes with a sense of responsibility, doesn't it? I mean, we need to make sure that this future is one that benefits all of humanity, not just a select few. That's a really important point.
It is. It's a collective journey, and it requires wisdom, compassion, and a willingness to embrace both the opportunities and the challenges that come with it. We need to be thoughtful and proactive in shaping the future of AI, making sure it aligns with our values and our aspirations for a better world, a more just and equitable and sustainable world. That's what it's all about.
Absolutely. Well, this has been an incredibly insightful conversation. I feel like we've only just scratched the surface of AI, LLMs, and deep learning.
We have, but that's the beauty of it, right? It's a vast, ever-evolving field, always more to explore and discover.
You know, it's funny, right? Like just a few years ago, all this AI stuff, it felt like, something out of a sci-fi movie. And now it's like everywhere. It's becoming part of our everyday lives.
It really is amazing how quickly this field is advancing, and it doesn't seem to be slowing down anytime soon.
Yeah, and that's why these conversations are so important.
Yeah.
Like we need to understand what AI is, how it works, and what it means for, all of us, for our future.
Wow.
We've covered so much already. The basics of AI, those mind-blowing LLMs, deep learning. But before we wrap things up, there are a few things I've been thinking about, a few questions I'd love to get your take on.
Yeah, shoot.
Okay, so we talked about, remember those techniques for improving LLM efficiency, pruning and quantization, was it? Are there any downsides to those? I mean, it seems like there's always a trade-off when you're trying to optimize something so complex.
You're right, there are. While pruning and quantization can make things much more efficient, they do have some drawbacks. Too much pruning, if you go overboard, sometimes that can actually reduce accuracy. Like imagine you're trying to streamline a recipe, right? You take out a few ingredients to simplify things. Sometimes it works out great, but other times you end up with a dish that just doesn't taste quite right.
Yeah. So it's like a balancing act, right? Like finding that sweet spot between efficiency and making sure it still works as well as it should. Yeah. What about quantization? Doesn't it run the risk of losing information when you condense it like that?
Yeah, it can. Quantization can introduce errors if you're not really careful about how you're condensing the information. It's a little bit like trying to sum up a really complex novel in just a couple of sentences. I mean, you might get the main points across, but you're definitely going to miss some of the nuance.
Right, you lose the details.
Yeah.
So it's like a constant challenge for researchers, right? Trying to find new ways to optimize these models without making them, less effective.
Yeah.
And speaking of challenges, we've been talking about these huge data sets that are used to train LLMs. But what about the quality of that data? Doesn't it matter where that information is coming from? Like if you're feeding an LLM biased or inaccurate data, isn't it just going to spit out more biased and inaccurate stuff?
Absolutely. The quality of the data is super important. I mean, if an LLM is trained on data that's biased, it can just perpetuate those biases and produce outputs that are, unfair or even harmful. It's like, teaching a child using outdated textbooks. Those books might have outdated information or perspectives, right? And that's not going to help them learn accurately.
So it's not just about how much data you have. It's about making sure that data is good quality and it's diverse and representative of, the real world. We don't want to reinforce existing inequalities or prejudices.
Exactly. And that's a huge challenge. I mean, especially given the massive amount of data that we need. But researchers are working on it. There are a lot of efforts underway to develop techniques for identifying and mitigating biases in training data. It's definitely an ongoing area of research.
It sounds like it's a never-ending race, right? As these models get more advanced, so do the challenges. But I want to kind of shift gears for a second and talk about the human side of all this. We've explored all these amazing technical things, but what about the humans? What skills, what qualities are going to be most important in this world where AI is becoming more and more prevalent?
That's a great question. And I think, while AI will definitely automate some jobs and tasks, it's also creating new opportunities. And it's going to put a premium on certain human skills, things like critical thinking, creativity, problem solving, adaptability, emotional intelligence. These will become even more valuable.
So it's not just about being tech savvy. It's about being human savvy, being able to think critically, to adapt to new situations, to connect with other people on an emotional level. Those are the things that are going to set us apart.
Exactly. And lifelong learning is going to be super important too. The world is changing so fast and we need to be constantly learning and adapting. It's not enough to just have a degree or a certain skill set anymore. You have to be curious, adaptable, and open to new ideas.
It's like that saying, the only constant is change. And with AI, that's definitely true. But let's end on a positive note here.
Yeah.
Okay. We've talked about some of the challenges, but what about the opportunities? Like, how can we use AI to, make the world a better place? Not just for us, but for like generations to come.
That's what I'm most excited about. I think AI has the potential to solve some of the biggest problems that humanity is facing, developing new cures for diseases, tackling climate change, improving education, creating more sustainable cities. It could really be a force for good.
That's a great point. And it reminds us that, we have a choice in how we shape the future of AI. We can use it to make the world a better place, a more just and equitable world.
Absolutely. It's up to us to make sure that AI is used ethically and responsibly for the benefit of everyone, not just a select few.
Well said. It's been an amazing conversation. Seriously, we've covered so much ground today, and it feels like we've only scratched the surface.
It's true, but that's the beauty of this field, right? There's always more to learn and discover, and it's changing all the time.
Well, to our listeners, thank you so much for joining us on this deep dive into the world of AI. Hopefully you learned a few things along the way.
And if this conversation sparked your curiosity, please, keep learning, keep exploring, and keep asking those big questions. The future of AI is being written right now, and we all have a part in shaping what that looks like.
That's a great message, a great note to end on. Thanks again for joining us on this episode of The Deep Dive. See you next time.